I've seen some inaccurate weather conditions in video games, but this one really takes the cake. These aren't even tornadoes! Super Mario Galaxy, you did great on so many things, but when it came to this, you kinda dropped the ball. We might end up talking about Super Mario Galaxy a few times since there are so many different galaxies that have weather, such as the dreaded Snowcap Galaxy. I got stuck on catching the bunnies here as a kid. I still never want to go back and play that mission again. Luckily, we're not going there. At least not this time we're not. Today, I'm focusing on my second least favorite galaxy of them all, Dusty Dune Galaxy. Now, I don't think Dusty Dune is inherently bad. I just got sick of it rather quickly. This galaxy has the greatest number of stars out of any location in the game, and with how many times we've seen the desert aesthetic, I was not about to fall in love with this place. While it is very creative, I got sick of the desert quickly. Not to mention that while Mario Galaxy has an amazing soundtrack that I listen to on repeat, this song is not one of them for me. So you might be thinking to yourself, Sophie, are you going to discuss how deserts become deserts? Well, that is a good question for another time in a different game. In fact, I have a thought about that, but not today. What exactly did I find in this galaxy then? It's kind of sunny. Well, I found the coolest thing ever. I found a tornado. On the surface, this looks just like one. It rotates counterclockwise like a tornado would. It has strong winds. So that's it. It's a tornado. It's perfect, right? Right? Yeah, I wouldn't be sitting here if that was all there was to this. This is not a tornado, and I can prove it. We gotta chat about how a tornado is created. So how does a tornado form? Well, the first thing that normally happens is the formation of a thunderstorm. Except, that's a bit of a problem. We're in a desert. Thunderstorms are not exactly common here. Luckily for us, thunderstorms can occur in a desert. How? Well, let me tell you. I'll give a relatively brief synopsis of how thunderstorms form since they're not our main objective today. There are three things we need to form a thunderstorm: moisture, instability, and lift. Moisture is the amount of water vapor in the atmosphere. Instability occurs when there is warm air that rises when it's given a bit of a push. That push is known as lift. Lift occurs because, as the sun heats the Earth's surface, some heat is transferred to the air, which creates different air densities. This difference in air density is the main source for lift. In the desert, where can we find these things? Well, moisture isn't easy to come across, given that a desert is normally extremely dry. This is not impossible, however. There's a boundary line known as the dry line, which separates moist air from dry air. If a desert has this feature over it, there will be moisture in the atmosphere at bare minimum. This dry line can also act as a source of lift given the great difference in said moisture. As for instability, well, the sun increases the temperature of the already warm air. Not to mention the moisture difference we see in a dry line also acts as a form of instability. Given these factors, we can indeed get the three ingredients needed to form a thunderstorm over the desert. Another thing that we need for tornadoes to form from these thunderstorms, or as I like to call it, the secret fourth ingredient, is wind shear. Wind shear is when the winds are blowing at different speeds or in different directions when it increases with height. For wind shear to be conducive to producing tornadoes, wind should increase in strength as we ascend in the atmosphere, and wind direction should be veering, which is defined as a changing of the wind direction in a clockwise motion. These factors usually indicate the movement of warm air, making conditions ripe for tornadoes. Once the thunderstorm is formed, the warm, humid air rises and the cool air sinks, resulting in air currents spinning around inside the cloud. As this cloud starts moving vertically, we can see this rotation at the bottom of the cloud. This is called a wall cloud. If this rotation continues to occur vertically, and if it touches the ground, that's when we get a full-fledged tornado. Except, there's a bit of a problem we have. I went all over Dusty Dune Galaxy. I played through every mission. I scoured every nook and cranny. There is not a single thunderstorm in Dusty Dune Galaxy. All that's here is a nice blue sky. There are no thunderstorms to be seen anywhere. Given that we don't have a thunderstorm, these can't be traditional tornadoes that we're seeing. But what are they then, if they're not tornadoes? There are a couple things out there that are similar to tornadoes. One such phenomenon is a land spout. A land spout is a tornado that forms while a thunderstorm is still growing. The spinning motion that we see originates near the ground. Yet, with this, we still have the same problem. We need a thunderstorm nearby for a land spout to form. Okay, so what are our other options? Well, this could also theoretically be a gust tornado. What's a gust tornado? Well, it's a small and weak whirlwind which forms as a result of small winds that occur when cool air sinks. They do not connect with any rotation that occurs in the clouds and technically aren't tornadoes either. Yet, even with this, we still have the same problem. We need cooler winds from a thunderstorm for this to form most of the time. We don't have anything like that in Dusty Dune Galaxy. All we have here is a rotating column of wind that has just like sand that's spinning counterclockwise. So, what could this be? If it's not a traditional tornado, a land spout, a gust tornado, or anything that comes from a thunderstorm, what is it? I'm not going to lie to you, I actually had to do some digging around. I think I have an answer though. Have you ever heard of a dust devil? Or a dirt devil, depending on where you're from. I think that's what we're dealing with here. You may be asking what exactly that is if you've never heard of it before. I'm happy to tell you. According to the American Meteorological Society, a dust devil is a well-developed dust whirl, a small but vigorous whirlwind, usually of short duration, rendered visible by dust, sand, and debris picked up from the ground. Okay, finally, there's something without the mention of a thunderstorm. Now we're getting somewhere. I quickly took a look at how a dust devil forms. According to the Reno, Nevada office of the National Weather Service, for a dust devil to form, the sun heats the ground, forcing the air to rise and creating an area of low pressure. Air then rushes in to fill that area of low pressure, and the circulation increases in speed and stretches. It'll pick up dirt, dust, debris, and similar things until eventually cooler air hits the circulation and ends it. The typical diameter of a dust devil can be anywhere from 10 to 300 feet, with average heights of approximately 500 to 1,000 feet. These are considerably smaller than your average tornado. Given this knowledge, let's take a closer look at the Dusty Dune circulations. These areas of circulation seem to be a lot smaller than a normal tornado. While I don't have the official scale of things in the universe, although, let's be honest, I'm sure Game Theory has done an episode on Mario's height or something like that, it seems that the circulations are far too small to be on the same scale as tornadoes. Some of them are barely taller than Mario, namely the ones with big eyes. I'm not even gonna try and justify that one weather-wise. Weather doesn't have eyes like that. Anyways, if we look at the smaller ones with eyeballs, they have junk and dirt rotating in and around them, just like a dust devil would. Looking at all the circulations throughout Dusty Dune, they're all the same colors as sand and dirt, the same as a real-life dust devil would be. Their relative strength is even similar. These aren't causing major damage to areas they happen to come across. Granted, wind speeds can reach up to 60 miles per hour in a dust devil, which is still relatively quick, but they don't always reach those speeds. These circulations must be moving pretty quickly though, given that Mario's arms act like a literal helicopter after he enters one. No, I don't understand how that works either. How on earth his arms aren't straight up broken, I have no idea. If I really wanted to get nitpicky, I could even argue that the soundtrack for Dusty Dune Galaxy sounds like there's wind blowing in the background. Given this evidence, it seems that we have our answer. I can't believe it, but as it turns out, the tornadoes in Dusty Dune Galaxy aren't tornadoes at all. They're dust devils. You know, maybe this means the tornadoes in Skyward Sword aren't real tornadoes either. Perhaps I'll save that idea for another time. Thank you all so much for watching. If you enjoyed the video, be sure to leave a like and subscribe. I'll see you all in the next one. Have a good day.